Hey guys, today we're at question number 216, I believe, for Devops and SRE questions, interview questions. This is less of a question, more of an overall broad view of a topic. So the topic here is latency. If you get into a system design interview for DevOps, which you're more likely to get one for a senior role than not, in that case, you would have to know some of the latency numbers, and I'll explain what they are in just a second. Uh, Even though you will not be asked directly about those numbers because nobody expects you to memorize these numbers, but for you to answer a system design question that has to do with millions of requests or has different components in different places, especially for a distributed situation or the system design, you have to know at least relatively which ones, what latencies each component presents. For that, I suggest to you that you memorize 5 or 6 of the latency numbers, even though you will not be asked them directly, but having them in your head will go a long way in talking intelligently about the design that you're proposing. So, what are they? First of all, before I get there, uh, quick summary of the numbers. It's pretty trivial, but I just make sure that you know this. So there's in a SaaS world, like if you're going on a website, the expectation is the response to the user should be less than a second, preferably maybe half a second. So if I'm clicking on something, I shouldn't have to wait more than half a second, or at the very most a second, get a response back, because then people get distracted, people think the system is slow. So that's your starting point. That's the end result of all the calculations and the back end things and front end things that you were doing to present the user back what he or she's looking for. So that's your starting point. Now, there are about five components you have to know what the latencies are. So first of all, the memory, RAM on the computer, the local hard disk, let's say an SSD disk, latency across a single AZ, within the single AZ, latency across multiple AZs that are in the same region, a expected latency of a database query that's simple and when the data is actually in memory. And then the last one is going to be if you have a cloud function or a Lambda function, how much time does it take for the initial Lambda function to run? So once the Lambda function is memory, it's super quick. But when you call it the first time, there is a significant delay. So what are these numbers? So RAM, so before that, also, I wanted to tell you, so there's second and there's milliseconds. So that's 1,000 milliseconds make up 1 second, and 1,000 microseconds make up a millisecond, and 1,000 nanoseconds make up a microsecond. So that's your scale right there. So RAM, generally speaking, we're talking about in hundreds of nanoseconds. It's the fastest thing there is, except to cache. Cache is even faster, but you can't possibly memorize all these numbers. So that's the fastest thing. Then you have local disk, like SSD disk. Those are, I think, I'm going to look this up now. On average, maybe 50 microseconds. So microsecond, that's still really, really fast. Then we have numbers across network, right? Within I believe that within the same AZ is less than a millisecond. If you're going across AZs in the same region, it's like 2 milliseconds. Then you have a simple database query that runs in memory. That takes, I'm gonna look this up now, that's about 5 milliseconds. So if your application needs 20 queries to run, they add up eventually. The last one is the initial Lambda function. The initial Lambda function takes about 200 to 300 milliseconds. So these numbers, even though you don't have to memorize, at the very minimum, you have to know what the relative numbers are, which one is fastest, the second one and the third one, and so on and so forth. Because when you're doing system design problems and you're having to solve, you're having to at least intelligently talk about the design, you will be asked, if I ran a million requests like this, how long will it take? So that gives you some idea, right? All right, I hope we found this useful, and I will see you in the next one.